Alright guys, here we are. I'm going to show you how we step through the weather portion of our spaceport project here. So anyway, I got a page already set up. You go to the STEM Plus C website, go to weather and winds aloft. And then this page takes you to several links here. Today I'll focus on the prediction website. We'll talk about these ones, the local weather and the winds aloft. In the next video. But the prediction website, you click on that and that's going to take you to the Habhub prediction website, and it drops you here in over in Cambridge, United Kingdom. What we're going to do, we're going to zoom out, come out over here, zoom in on Mexico. We're going to go New Mexico, and we're going to get out to spaceport, which is right there. Zoom in on it, and we can even click on satellite here, and let's see, we are going to actually launch from the firehouse over here. So what we're going to do is we're going to set our location, set with map. I'm going to click on that. Now click the desired launch location on the map, and I'll set it right there. And there you have it. Let's see, launch site, custom post, please save your location, set with me. Oh, here it is, save location. So there's the location, altitude, we're going to put that in there in a minute, and I'm just going to call this spaceport. And the altitude there at, so I save it, the altitude, let's see, spaceport, New Mexico. Altitude, let's see what it is. Spaceport, New Mexico altitude. New Mexico spaceport is 4,595 feet or 1,400 meters. So altitude, we'll put it in feet. It was 4,595. 4,595. Site named, I thought I called it spaceport already, but we'll try again. Save. Now I think we have it saved. Let's see, 4,595. Actually, it wants it in meters. So it's 1401 meters. Come back over here, 1401. Okay, launch time and UTC, launch date. We'll talk about ascent rate, burst altitude, and descent rate. So what I'm going to do here, I'm just going to put in a fictitious date. Let's say we're going to launch our balloon. Let's say today is the 4th of May. May the 4th be with you. Let's just say we're going to target May 6th. So Monday, May 6th. And let's say it's going to be in the morning. So how about we say like 1400 Zulu, 1400 Zulu. And I said we're going to do May 6th. So we'll put that in there. Ascent rate. This is how fast we predict our balloon with the payload attached to climb. So I'm going to just leave that at 5 meters per second. That actually is a pretty good guess. Burst altitude. Arbitrarily, we can leave it in here at 30,000 meters. 30,000 meters is roughly 100,000 feet. We can come over here, go meters to feet, and we can type in 30,000, so 98,425 feet. So we can put 31,000 in here, whatever you're happy with, and we'll say a descent rate. Now this, the way this program is set up, it's set up for near space ballooning. So what this thing's going to do when I click run prediction, it's going to give us, run the prediction here, and what it does is it predicts based on today's weather forecast for how the weather is supposed to be on May 6th, at 1400 Zulu. So this is spaceport. That's where we launch from. So our balloon's going to travel up, and at 5 meters per second, this is the trajectory it's going to take us on. And it's saying this is where the balloon will burst. Now, the rest of the line here is the free fall at a rate of 5 meters per second. So like I was saying, the way this calculator is set up is it's set up to be for near space ballooning, and your balloon gets up there, it bursts at 31,000 feet and or 31,000 meters, and then your payload parachutes back down to the ground at roughly 5 meters per second. So anyway, this is the predicted path, and this is where you would go pick up your payload. Now what I do for spaceport, since we don't really care about this tail here, what I do is I just put in a descent rate of like 10,000, and then I click run the prediction, and there you have it. So now this would be launch to the point where we would release at 100,000 feet. And it's going to give you some information up here. Current miles range 57.1 kilometers, flight time an hour and 38 minutes to get up. So at this point right here, we've traveled downrange 57.1 kilometers, and it will take an hour and 38 minutes to get up to that altitude. So anyway, that's how to use this prediction website. You can mess around with it, you can change data, you can change the ascent rate. There's another little tool here to use the burst calculator, and we'll click that. So let's assume that our payload mass, I'll go over here and we'll actually use our Spaceport 2017 numbers. So here it is right here, Spaceport, where is it? Spaceport 2000, Spring 2017, Spaceport America. I'll scroll on down here, and there's some good information here about the airplanes. Planned release point from 3,000 gram weather balloon, 100,000 feet, ascent time 67 minutes. Okay, RV jet airplane weight 2,400 grams. Use 2,300 grams for the burst calculator. Neck lift of the balloon, we'll talk about that later. That's something for when we fill our weather balloon. So our RV jet airplane weight was 2,400 grams or 2.4 kilograms. So we'll go back over here and we'll simply put in 2,400 grams. K-Mont balloon, we are going to use I think I use what I say, K-Mont. RV jet, neck lift. Let's see, do I have... No, I don't have the balloon data right there, but I do have the balloon data down here. So this was RV Jet 003, scroll on down, RV Jet 003, 2,400 grams, balloon size was 3,000 grams right there. So click back on over here, K-Mont 3,000 gram. Target burst altitude, I'm going to leave that at something higher than 100,000 feet. So I'm going to put in like 35. Or wait, let's see, we can do this. We can do target ascent rate. I'm going to put in a 5 meter target ascent rate. So here the burst calculator comes out, it says burst altitude, we should get up to 36,814 meters in this balloon. So that's well above our altitude. Time to burst, about an hour and 17 minutes. That tells you the volume of helium that you're going to need to use, the ascent rate, our neck lift, and anyway, those values. So you can go ahead and click use values, and it will dump those values into the prediction website, and then we can change this number back to our 31,000 meters or 31 kilometers and click run prediction. Now you get a little bit better idea of the path. Another thing we can do, we can play around the dates. So here would be for tomorrow. Here would be for if we were going to do this today on May the 4th, let's say Zulu time 2500Z, run the prediction. So there it is. Be out over the White Sands, downrange. Let's see, 63 kilometers downrange there. The other thing we can do, we can put it out into the future. So let's say the 9th of May. Click run the prediction, and you can see there's the path of our balloon at that time. And that would be the release point, and then obviously fly back to Spaceport America. We can come back over here to weather winds aloft. I'll show you the winds aloft that correspond with what we're talking about today. So here's weather winds aloft. We can zoom in on Albuquerque area here. And actually this isn't the chart I like. I like this chart better. So if we come over here, and then you go to, let's see, I want the map. I don't want this. Let me go back. Right here. So we got wind speed. We can click what altitude we want. So let's just say 48,000 feet. And that's today. So you can see, oh, I got to sneeze here. You can see there's relatively high winds out over New Mexico at this time. Keep clicking forward, relatively high winds. Still high winds, that's Sunday. We can even click all the way, it gives us, we can go quite a ways into the future. 7th, so see the winds are predicted to start coming down a little bit. Here's the 6th. So anyway, this is how you evaluate the winds aloft here. And you can take slices from any altitude. You can see this little upper level low right here that's forming out over Nevada and California, and that's at 24,000 feet. I like to play around with this thing because it gives you an idea of which way the pressure systems move. And this little low, this is a really good, this low pressure system right here. These are really good systems to have fall in place for when you want to launch. So if we are going to launch on Monday, the 6th of May at 12Z, if we're going to launch from like right here on the Nevada-California border, that would be like perfect because there's barely any wind. And I'll show you, let's go back to the predictor here and we'll mess around. We'll reset our position here, and I'm going to put it over that border there between Nevada and California. Let's see, where do we want to go here? I'm going to go back to map, and I'll scroll right on in. There's Vegas, there's Death Valley, and we'll say we're going to launch from right there. So we're going to set with map. We'll just say we're going to launch from right there. Oh, did it set? Now click your desired launch location. Let's just click right here. There we go. We got it set. Go back to satellite. Now let's do a prediction for, the 6th again. 6th of May, run the prediction. And look at that. Look at how tight this pattern is. Downrange, the balloon only travels 20 kilometers away from the launch site. That would be like a perfect setup for Spaceport. So hopefully, and our dates are October 12th and 13th, we're hoping for the best, but hope we have this kind of wind pattern to work with. That would be just crazy ideal. Anyway, that's all I got, guys. I'm sure I'll probably generate some questions from this, but look forward to doing some more of these little predictions with you guys, get you used to doing this. The next thing I'll do is do the filling the weather balloon with helium. I'll go through that technique and how much helium we need to use in the whole 9 yards, and the techniques that we've used in the past for doing this. Anyway, thanks guys. We'll talk to you soon.